entering the midnight hour here on the Eastern Standard Time of the 24-hour, which means we're halfway there, and we've had a great lineup so far. We're now getting into the part where we're looking at some of the new entries into the places and spaces envisioning intelligences. And just as a reminder, the envisioning intelligences will be the next decade of the exhibit. And the MO there is to examine intelligences, including linguistic, kinesthetic, communication, musical, emotional, and other intelligences by biological and technological life forms, with a focus on collaboration and coordination across life forms and intelligence types, to inspire discussion about existing and future sensors and actuators, memory and reasoning, exploration and communication, plus shared goals and desirable futures. And this next entry is called Mind by our guest, Santiago Ortiz. Welcome. It's so great to have you here. And let me just get this set up here. Just to introduce, Santiago creates digital experiences that help people solve complex problems with data. He develops interfaces that allow for exploration, combination, deep understanding, and decision-making based on large, diverse, and dynamic data sets. He has experience as a teacher, digital media artist, interactive data visualization researcher, data scientist, product leader, and entrepreneur. He has lived and worked in South America, Europe, Africa, and North America, and lives in Palo Alto, California, which is where you are now?
No. Hello, good morning, everyone. Good night. No, I'm in Spain.
Oh, I see. Okay. Well, thank you for joining us. This is yes, it's great that you could make it and be part of this. And it's my understanding we're gonna have you lead the slides. And so whenever you're ready, feel free to share your screen and you can take us into some discovery on your work.
Amazing. Thank you. Yeah, let's start sharing. Uh, these are not slides, by the way. It's going to be a lot of stuff, including live demos, and this is how I like it. Mine, by the way, is the name of one piece, one of the projects I'm going to be showing today, but I will be showing much more and very quickly because even if we have an hour, I would like to talk a lot and show a lot of stuff. So I'm very excited because this is a fantastic context to talk about intelligence and to show work. I've been attending not every presentation, but a lot of them, and I'm very happy to see how the concept of intelligence has been enriched and has been addressed from multiple angles and perspectives. And that makes me happy because part of the theme of my presentation is how poor have been the conversation around intelligence recently, because they have been dominated by one particular paradigm, but by one particular community and particular biases and motivations, right? So it's fantastic to be here and talk about intelligence. Indeed, we talk about intelligence in humans and in animals, plants, and technology. I would like to extend even more the scope of the idea of intelligence. That I think it's also one of the motivations of what I'm going to be talking. Just let's go into it. One way to see it, and this is not an attempt to define anything, is more an invitation to think about intelligence in certain ways. Is more like an emergent property, right? We have mass, energy, information, and from those three things, very, very quickly and at all its scales and everywhere in the universe, information processes start happening that we could call computation. But also, the way I see it, very quickly, this computation in some ways could be understood as intelligence. Not to speak, let alone when you have a chemical complexity that could be called life, right? There, computation and intelligence becomes crazy. And this is going to be part of what I'm going to be talking about. So three main topics here, three main parts of my presentation. One is this idea of information being everywhere. Then I'm going to talk a little bit about the relationship between humans and machines. And finally, the idea of intelligence's ecosystem. Again, many of the things I'm going to be presented have been addressed in different ways. So I'm very glad. For instance, when we talk about intelligence more as a field within an ecosystem, the relation becomes even more important than the individuals or the entities. And I think with intelligence, that's also a very interesting way to look at it, because is it in the relationships and in the communication that the magic happens, I think. And of course, we have talked about collective and social intelligences. I'm going to also point into those directions, of course. So let's start with information is everywhere. And the way I do it, this could be done in multiple ways, but I'm going to go more into the human sphere, and I'm going to present a collection of images. This is 20 years of collecting images in which somehow information is there in the objects that surround us. And it's even presented as some kind of spontaneous data visualization, right? As it happens here in this particular image. It's a Bell distribution, right? A normal distribution. But you see here, it's a visualization of the behavior of people in this particular context, a gym. And I invite you also to look a little bit into the details of this image, because maybe there is more into it. I'm gonna come back to the image in a minute. So multiple images like this, in which in this case, the invisible becomes visible with a purpose in this case. So kind of the idea of data visualization, right? Make visible the invisible. So we have been doing that. And this is kind of visualizing a pattern that exists, but requires some technology in order to make it evident and visible, right? This, by the way, doing this has saved a lot of lives, because this vortex stays alive much more time than our intuition tells, or even the models are physical models at the time. So this conversation today is also about patterns and stable patterns, right? Making the invisible visible, of course, for different purposes. So all the images go a little bit in that kind of direction. This is Bogota, my town city. And this mural art piece here in the building, it's by Omar Rayo. It's kind of a prediction. It's a beautiful picture. So entities visualizing themselves, right? Like this flame here is a heat map. The very strong idea and very important that every time we look at something, there's a story, and intelligence is about collecting stories out of patterns or signals. Here there is a complex story out of just one static image, and that's beautiful, but that happens all the time with any entity that has the capacity to sense the environment. So this is the action and the visualization of the action happening at the same time, right? Real time. A donut chart. So geologists kind of reading our planet, and sometimes it's so literal in that it looks like if it was a visualization of itself, right? And I will be also talking a lot about education in this session, in one way or another. Many of the pictures I've collected come from social media, Twitter, and the like, because it's kind of a discovery. A lot of people discover that idea. Look, the object, the signals it sends is like the visualization of the story of the usage of the object. So a lot of people tweeting or publishing these kind of images. This one over here is particularly sad. The homunculus, which is a representation of the human being, where the surface of the skin is proportional to sensory inputs. So, which has correlate with the brain, right? With the somatosensory strip and the motor strip, which are one mirror of the other in our temporal lobes. So it's fantastic how the map and the entity that creates the map are also correlated, right? And I think another theme in these images is how easy we are lost in our own maps, right? Or the classical confusion of the map and the territory all the time. And this is not only for humans, right? That happens with any sensing system. This one is quite a mystery because it seems that the elevator is more used to go down than up. So this one is kind of difficult. In workshops, I present this image and we discuss what could have happened here. There are fantastic theories you can think on your own. So light has no shade. Interesting. So a picture and a representation of every city mentioned on any Wikipedia, in a Wikipedia page, and the map and the territory like matching together very well, making the invisible visible, of course. We create maps that are sometimes same scale as the territory we're mapping. Maybe you have read Borges' story about that. Not here. Parking lot, the snow. Yeah, we humans, intelligence. A classic in data visualization humor.
I think, yeah, I think it went out for a test there. So sorry about that, Santiago.
No worries. This one is beautiful, the decline and fall of the Roman Empire and the visual cues. You can sort the books in the rather inverse way, just to have fun. This is, I think this one is Roomba with a LED and a camera, long exposure, and this is the competition. So it's the idea of visualizing the algorithm in a way. I love it. And it's also a kind of analogy of how science can study, research, define, understand intelligence. We cannot go and look into the, let's call it, intelligence algorithm. The only means we have is to look at the intelligence happening. So the algorithm, in this case, yes, we could have access to the code. But if we don't, as in the case of at least of life and biology, we can only see intelligence happening, the algorithm happening. And from there, trying to infer aspects of inner qualities of that intelligence, right? This is what happens here. And comparing is always a good idea. This is a solarigraphy. So it's a pinhole camera, but you keep it for 6 months. This I did from this very house. So winter months and summer months here in the top. 6 months photography. This is an interesting statistical distribution, right? This guy here is studying the statistics of a squash. I think this is wrong, but I find the image interesting. I don't think there are this much sugar on a Coca-Cola can, but anyways. Whoop, 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 whoop. Yeah, this is real. This is, as it says, real. Donald Trump. He himself tweeted or published this after witnessing firsthand. This is cute, right? Again, map and territory. This is firsthand for you in modern times. The letter case, literally, with spaces for each character of the size of the frequency, of course. So it's a beautiful visualization, spontaneous visualization of, in this case, I guess, English language. So back to the weights, lifting weights distribution, the normal. So you might have noticed here in the 95 and 100, right? So this is where the normal distribution breaks because we are humans. So we follow patterns, but we also follow other patterns that break other patterns, etc. So I call this the Jim Bro distribution. Okay, now into relationship of humans and machines, right? There are interesting things to say about it, of course. So this is Joshua, this is Edward. Joshua is a journalist, and he interviewed Edward in a memory contest, for a memory contest. Edward told Joshua, I can train you and you become a champion. Joshua didn't believe. So as a curious person, as a journalist, he decided to try it. He trained, he won, right? I think a state level contest. So the message being that everyone can be a memory athlete. It's really about training and learning the techniques like any sport. So I'm going to present one technique that I think it's fun. I've done it. It works, but it requires work. It requires that you write a list of the first 900 numbers from 00 to 99. And for each of these numbers, you kind of write a sentence, but you have to identify the entity, the actor, right, the subject, the verb, and the passive object. So, and do it in a way it makes sense regarding the number. So Leo Messi is kicking a ball. That one is easy. Then 45, I choose atomic bomb blowing up a city. 69, I had a lot of options, but I choose astronaut stepping on the moon. right? So you do that with all the numbers. Then, next step, when you are presented with any six figures number, what you do is you take out the first two digits, the first number, two-digit number, and you think about the actor related with this number. 45 in this case for the verb, and 69 for the passive object. So according to the three numbers I showed before in the sentences, you should be able to associate an entity doing something to something else, right? So try to think about what would be the representation of this number, right? And indeed, it's Leo Messi blowing up the moon. And then if you combine this technique with memory palaces, for instance, in which you create one of these situations and you put it, let's say you're thinking about your own house, you go inside your house and you start putting this kind of crazy surrealistic situations in different places, you can memorize very long numbers, right? With numbers with a lot of figures. Part of the magic here is that humans are more capable of memorizing, of course, actions, things that happen, but also the more surrealistic, the easiest for us to remember. So that's why also this technique is very powerful, because it creates impossible combination and then make things more relatable or more memorizable, right? So the idea is that one way to understand a key difference between humans and machines is that machines use numbers to memorize stories and humans use stories to memorize numbers. So that already sets a little bit the basis of comparison and relationship within humans and machines. Although this might be changing in some ways, and I'm going to comment about later in the presentation. Now I'm going to show one project. Part of what I'm going to be doing in this presentation, showing different projects that in one way or another connect with what I'm presenting. And this is the project called Mind. And it's an exploration, a little bit like in the Roomba algorithm being represented, visualized by a long shot of its behavior. Here, the strategy is to use an LLM, in this case, ChatGPT, and using the API that allows me to send a lot of completion queries. And I'm just asking it to complete the sentence intelligence is. So the same model with the same parameters, in particular, the most important one here is temperature, set at the same level, is just repeating the same task once and again. We know that LLMs are stochastic. We know that they have different answers to same query. But we also know that for each next word, there is a distribution, a probability associated with the next word that can complete the sentence built so far. And one of the motivations for this experiment was to try to understand those distributions. So here we start. Intelligence is, and the first word that comes, or the third really after intelligence is 50% of the chances is for the word the. But then a kind of a big chunk of chances or probability is the word a. And then the third candidate is defined, etc. And then once, let's say, it chooses one word, now the same process happens again, a new distribution. In this case, for instance, the entropy is larger, meaning that now you have many more candidates, so a more even distribution of candidates, with only one slightly more probable than the others, which is complex, and then the same again and again and again. So now an entire sentence is being created, right? There are ways in which if one word is a little bit strange, maybe the next one also as well, and then it starts going offset. In this case, I'm not sure I have a good example of that, but in some cases, this had happened with other initial prompt. So this is a tree, and it's being said that LLMs are only next word probability machines, and I agree. But at the same time, if you think kind with a sort of quantum mechanics perspective of this, like the wave equation of an LLM, in reality, is an infinite tree of probabilities for each sentence, because each next word, yes, there is a distribution, but then each of those will have its own distribution. So really, you have a universe of probability for each completion as a possible state in the future. So I like that you can go from just one word to think about an incredibly deep tree of possibilities, right? And here on the left, what we have is, if I choose one sentence, you see there is one particular path being highlighted in the left. What I'm doing here in the left is using the embeddings. And embeddings are ways to take any text and get a position in a multidimensional space. Embeddings is at the core of the LLMs. They are very important. They are a very beautiful tool. I love embeddings because you can do all sorts of things with them. You can compare text. You can visualize a lot of structure, especially if you have many texts. There are so many ways you can use and explore embeddings. In this case, embeddings, I using a principal component analysis, I reduce the dimensionality of the space. So we are looking at them only at 3 dimensions, of course. And in that case, a sentence that is being generated, a word being added at a time, it moves into this embedding space. And at some point, it stops moving very aggressively because each new word does not change very much. It's the semantic addition is marginal, right? There's no much more new. Sometimes, and this is part of the magic of visualizing these things, one single word can affect the trajectory of the generation of a sentence, etc. So it's the idea of an invitation to explore LLMs, to run experiments, and do not take them just as black boxes, because even if you look at the algorithm or at the structure, it's so big and so many complex things happen. There is a lot we can learn. I've done other experiments in this with this kind of idea of repeating, right? Repeating the same question or variations of a question in order to explore things such as the gender bias of LLMs, and trying to do clever experiments that go deeper than the guardrails, right? That really reveal the inner deep biases that these models have. And by this kind of approaches, you can do that, and it's a lot of fun, right? Okay, let's go. So now I'm going to show you a computer. Now that we are talking about huge neural networks and how complex are LLMs, etc. But I'm going to show you a computer that is capable of running ChatGPT 5.2 or actually any other ChatGPT, right? Or any other LLM or any AI. This one over here. This is a know-how computer. It's called that way. It's a paper computer. And you only have 5 lines, 5 commands. But this is a Turing complete machine. So these 5 are enough to essentially write any program. Essentially, any program we have created can be created this way. You can even build a pseudo random number generator here with this code, and then use that as random numbers. You can do anything, and you can code, of course, ChatGPT here, and start the code and the initial configuration in one of these cards is gonna be a larger card, and it's gonna be you will need more paper. in order to be able to really go to all the computational steps. 8, one do, 16 lines of code, one do, but the same computer, just more slots, can execute these intelligences, right? These algorithmic intelligence. And that for me is revealing, because a lot of things happen when you think about a ChatGPT running on a paper like that, and humans just moving pieces of paper in different directions, and nonetheless doing those amazing linguistic computation. It's the relationship between the intelligence, the code that you can transfer into any machine. That's something already. We cannot do that with biological intelligence. I think already some of the people here mentioned that this crazy idea of splitting mind and body, impossible for understanding biology. Mind and body are two ways to look at the same thing, but with an LLM or any algorithm, you can do that separation and execute any program, for instance, here in this paper computer, right? So, by the way, I run a workshop called Intelligences, and this is one of the activities we do. We play with this kind of paper, with this paper computer in particular, but other computers that we build ourselves and that learn from patterns, etc. So let me show you a conversation I had with ChatGPT, by the way, very quickly. I asked it to give me all the math subjects and K to 12 program, right? Very thorough, very complete. Please give me an example of a very difficult problem for each of these subjects. Okay, very well done. Very impressive. For each of the above problems, assess the likelihood that an LLM can solve it. This conversation, by the way, happened more than a year ago, and it already can tell it's easy for it, right? Likelihood very high. So each of these problems, the LLM can solve. And again, this is ChatGPT 4. Very high, or here high. So of course, each of these problems LLM can solve. So that makes me think, if how we educate our kids is by providing knowledge about things that LLMs already know how to do much better, more than educating, what we are doing is training little humans to become replaceable by machines. That's the challenge of education right now. So even when I'm seeing those videos of ChatGPT or any LLM being used as a tutor for the kid, and the machine teaching the kid, it's the same feeling. Wait, there is a problem here. The machine teaches the kid. The kid grows up knowing how to do way less than the machine can do. What's our future in that scenario? And I think the problem is not only what mathematics we teach, or of course this is generalizable for other areas. I'm going to talk here about mathematics. Is not only what kind of mathematics, but what is the purpose and how we expect kids to learn mathematics. And the problem goes way before AI and this new risk of being replaced by machines. And it's this idea that mathematics is about performance, that kids learn mathematics to become good at solving certain problems and that you can assess. Whereas if, especially in this new context, we decide to go in a different direction regarding mathematics or any other subject, and we think that the way and the difference between the deep epistemological difference between humans in connection with mathematics respect to a machine that is capable of performing very well is that humans enjoy doing mathematics, and that by means of enjoyment and happiness and curiosity, they manage, or we manage, to also spread mathematics into other areas of knowledge or even creativity, uh, in non-expected, non-performance, uh, assess asset way, in ways you cannot assess or evaluate, right? So that, I think, it's a clue about how we could change the way we educate our kids. I think this new scenario of machines doing those things we are teaching our kids how to do, this new scenario is going to put pressure into moving education in different directions. And I hope so, right? I'm going to show very quickly another project talking about human machine collaboration. In this case, explorations I've done for how to use LLMs. The techniques I'm using here in this particular project are not new. This is what is called RAG, which is one clever way to use a knowledge base and an LLM to create meaningful conversation about this particular knowledge base. But what I'm also trying to do, and maybe this is a little bit uh, more unique, I hope, it's also integrate that into the visual interactive experience, right? So this is a fantastic project by well, the interactive project I built it, but working alongside a team of artists led by Susana Mejia in Colombia. They have been researching the coca leaf and the culture around and the science around and the multidimensional reality of the leaf, of the plant. And they share with me this fantastic amount of information, and this is just an exploration. I'm gonna go quick on this, but the idea is just that you can make questions like the origin myths of the plant, for instance, and in real time, and you, by the way, using embeddings, you see that right away it is a search, a semantic search machine that points to the interesting contents into your knowledge base or database related with what I'm writing here, right? And now I'm gonna send the question, and of course, these relevant contents will be sent as context to the LLM, and in a minute or so, I'm gonna have an answer to my particular questions, right? This is the answer. So this is one way in which new interfaces can be done, which is through natural language, through questions and answers. And here I am interacting with data in very different ways. I'm very excited about these possibilities. This project is very beautiful, and I recommend to check it. It's called the Coca Archive. Okay, but I have so many other things to show, and I think I need to accelerate. Kirigami, it's another human-machine collaboration project, this time for writing scientific paper. And here what you do is, as a paper writer, you focus on relevant questions. For instance, what are the limitations of your study? So you have this question and you focus on that. You do that with 16 questions that you are asked, and this is aimed to help people that struggle writing papers, which might be the majority, especially if it's the first academic or scientific paper you write. Is extremely painful and stressful because you mix structure and content and you don't know how to start. Here you always have a next question you can answer, and let's imagine I answer somehow this future. What future research do you suggest? This is being sent, and now it activates a machine that connects all the information from the answers and creates units. And then when you complete multiple units, a section is generated. Nothing is added here. All the information is information contained into the answers. This is not using ChatGPT or LLMs to help them create a paper. It's just restructuring the information they use it with. The LLM is not an expert on your subject, and it is very, very clear that anything it says here, each statement and each reference comes from the author. Okay, so it's a different approach to using LLMs to helping people write papers. So this is Kirigami, and this is a startup I'm collaborating with all the engine, all the system behind, and the visualization. Right? Okay, let's go to another project or part of the presentation. So now we enter the third part of my presentation, which is about intelligence ecosystems. Okay, so one more project, collective future, that I think it goes in that direction of exploring a collective intelligence. This is Brett King. He has a podcast about the future. These are all mainly futurists, but also Scott Kelly, astronaut, and other very, very clever, interesting people. And from the podcast, we gather all the information of the interviews, very rich. Each person focus on one particular subject. I'm gonna make a question. Will humans go to Mars? I know this question is gonna be answered by a few people, and I know for sure that they won't, in general, agree with the approach, with the answer, and that's why I choose this question for the demo. So each of these, Ross, Scott, of course, Wanda, they have an interesting answer based, of course, in what they have said in the interview. So this is not inventing information. This is just using the information these people provide in order to answer the question. But then what I'm more interested in is in the relationships between these answers. And when two people agree, there's a green connection. It means agreement, and you can understand why these agree, or in which aspects they agree. And of course, more interesting for me, when there is disagreement, right? So here we have a red connection, very strong red connection. So a lot of disagreement in the perspective. This particularly is an interesting and difficult subject. So it's normal that you have these disagreements. And also in the meantime, there is a system maps being built. But for the sake of speed, what I'm gonna do is, this takes time, the system map. The idea is to collect, here we have it, to collect all the approaches, the ideas, this collective intelligence, and create a system map where all the entities are connected with each other through influences that could be negative or positive. For instance, radiation is very important, and it's negative respect to life support systems. Of course, radiation challenges the effectiveness of life support systems, and it also affects negatively the sustainable environment. But then if I choose sustainable environment, it has a positive connection, a good positive influence to technological innovation, etc. So it's really a system map, also with 3 leverage points: the public sector, let me see, citizens, and private sector. Here are the citizens, here is the private sector. So it's trying to build a collective intelligence to answer one particular question and to help solving problems. So this is the idea of collective intelligence tried to be used in a project. So I'm gonna just very quickly go through some what I consider could be an intelligence, right? So this is an algorithmic intelligence sorting algorithm. This is a typical, very interesting, beautiful algorithm. For me, algorithms are intelligent. They embed a lot of intelligence, and are intelligent because they represent human intelligence, but also they are intelligent by themselves in their own dynamics. Cells, in this case, performing mitosis, any life form is already infinitely complex, infinitely intelligent, right? Slim mold here, bees as individuals, as a collective. We know that as a collective, they are like a super agent of sorts. The cute animals, we we know and love, they radiate intelligence, and it's a type of intelligence that, of course, we can recognize, right? Because it's start being close to our own intelligence. For instance, emotions, which is only an expression of intelligence. We can recognize the signals, right? Dolphins, of course, pigs, of course. Here, this is more like a visualization, a real-time experiment, very beautiful, of bacteria evolving. And evolution on itself, for me, is an intelligent system because it creates all sorts of crazy informational processes and relationships between entities and the environment. You can look at intelligence at different levels of systems, right? Of course, it doesn't have to be an individual in the humans, in the Western sense of individual human or individual entity, right? We know that systems happens at all the scales, and if you put things interacting, and a system will emerge from there, right? A pattern, some stability, right? Humans, of course, having fun. Even this object, and this is one of the objects we play with in the workshop. We play with a lot of objects. It's a combination machine. It's a computer, and for me, this is an intelligent object, right? It already embodies intelligence, and it is capable of solving interesting problems regarding light. So it's a beautiful, intelligent object. This is from my octopus teacher documentary, and there is an octopus here hidden, right? We all know this. We are all friends of this guy over here. Of course, octopus, invertebrate, and yet extremely intelligent, right? Cities as emergent system. There's no one, even if there is a major, there's no one controlling a city, and it does have a lot of information flows, matter and energy flows, all the things you might recognize in an intelligent system. Humans, when people think about the pinnacle of human intelligence, they always think about, I guess, civilization, cities, large infrastructure, radio signals, things like that, right? This is also typical in science fiction, like the pinnacle of intelligence. If we are going to be looking for intelligence elsewhere in other planets, let's go for cities and signals. I think that is self-serving and very boring. I think intelligence, if we find it, same thing as saying life, if we find it, is going to surprise us. And it's much better to be open to the surprise, to try to already put in a box what we want to expect out of an intelligent alien, right? And I mentioned all that in this context of this image because if we think about human prowess, amazing thing, I do believe that these guys over here that were able to navigate thousands of nautical miles only by extreme sensorial compenetration with the environment and reading very weak signals. It's, in my opinion, it's as impressive as, I don't know, as getting to the moon or whatever the other technological prowess. In every culture, every individual, and not just humans, it's infinite in its complexity respect to the relationship with the environment again. So Porsche spider here, cute as well. And this is the quantum foam visualized in some crazy way. So this happens at the smallest possible scale. And even at the smallest possible scale, there is crazy information and computation going on. So really, for me, intelligence, an interesting way to think about intelligence is a property of the universe. It happens everywhere. It emerges everywhere. And if you mix chemicals with some energy, it's gonna be happening as well in ways that start resembling life and even human intelligence, right? And yet, this is how we are discussing nowadays the subject of intelligence. I think this linear representation in which we put plants here, and let of course outside other life forms, right? Bacteria or protists or what or fungi. No way. Maybe plants, but very much in the left. And animals, low. This kind of nomenclature. This is very pseudoscientific, and yet is being used in apparently serious conversation about intelligence all the time, right? Uh, and the cute animals that because they smile to us, we grant them the the possibility of being intelligent, right? This is highly, and then the AI that year by year is becoming more and more intelligent, so it's going to surpass human intelligence. Really placing intelligences in a single dimension is the worst way to think about intelligence. Intelligence, there's nothing more multidimensional than intelligence. Even the concept of multidimensionalism is already reducing the idea of intelligence, but we have to work with something. In any case, a single hierarchical way to structure this is more than that, this is better than this other, is not appropriate, right? And also actually because when we present this line, really what we want to say is this. Human, now Western and male values. This is the idea of again, the cities, the radio signals, the infrastructure, the guns, I don't know, right? So any other thing that do not have this kind of signals or telltales is not intelligent enough. So if you think about, we are just thinking like exactly the same as the conquistadores arriving to America. This idea, if they do not have boats or guns, they are less than us. It's the same idea. We didn't escape, but it's not a surprise. We are thinking the same way. We still think like conquistadores, and when we think about planetary exploration or looking life elsewhere, we still think like conquistadores. I think my surprise a little bit of my sadness is that this happens even in philosophical and scientific discussions, but it does. Okay. So defining intelligence, which is something I won't attempt, has a lot of problems. Let me show you very quickly a video here, just to exemplify how the discussion about intelligence more or less happens, in particular around the subject of AI.
Been hearing a lot about. So I'll start with the word intelligence. Intelligence is the ability to process information, take as input a bunch of information, and make some informed future decision or prediction.
So I love this course, and Alexander is fantastic. It's just about pointing to the fact that in order to be able to justify this conversation, that AI will become general or whatever, or super intelligent or whatever, fantasy or pseudoscientific concept, the best way for AI to be more intelligent than humans, you know what it is define intelligence in a way the AI is already better than humans. That's it. We made it. We made AI more intelligent than humans. And again, my issue here is not that I believe humans are more intelligent than AI. Is that you cannot compare intelligence, and intelligence is not a performance score, right? And certainly, if you define intelligence as a machine capable of prediction, and that's intelligence, machine learning, artificial intelligence already won and decades ago, right? So that's I have this question. What's the smallest island in the world? It looks like an interesting question, it seems, but it's only 5 seconds into you realize it's an impossible question. Or maybe it doesn't even have any sense, right? For any island, I can point to you to a smaller one, right? And this is not, I love this question also because it's not just about the space or size or geometry. It's also about time, right? Because no island is forever as well. And time becomes part of the conversation when you start thinking in smaller and smaller. So this kind of question, this is kind of language that looks from the outside as being intelligent and relevant and deep, but then you look into it and there is nothing there. This is another similar question. Can we build machines that are more capable than humans? And there is a lot of people discussing this, but really, this question has been answered already, and in the following way. Any machine, any tool, any technology humans build is more capable than humans. If not, why would be building those machines? So there's nothing there in this question. Every single tool, a hammer, a rock, if used as a tool or as a machine, a computer, a Casio calculator from the 70s, my paper color computer I showed before, all those and any other machine is more capable than humans. That's the reason we build, and not only humans, but other life forms build and use tools and technologies and machines. So it's an empty question, really. And again, part of the philosophical failure here is always thinking in this hierarchical and monodimensional way, right? What is best, what is above, always thinking like that lead us to poor thinking, I believe. And by the way, in science uses categories, but science very rarely needs hierarchies. So when in the discussion you get this idea of low, high, etc., it's already telltales of pseudoscientific arguments being made. Okay? And while we discuss AGI, superintelligence, or even conscious AI, this is what is going on, right? The real conscious entities are our friends, our cousins, our entities that in the phylogenetic trees are so close to us that it's just absurd to think that only one little dot in that huge tree has this idea of consciousness or emotions or suffering or happiness. This is everywhere in life, and still we think that the relevant discussion is conscious AI or not, consciousness can emerge from matrix multiplication or not. That's not the relevant discussion. This is the relevant discussion, I believe. And I'm going to present the one way to look at or think about ecosystem of intelligences. So you have culture, you have being, you have ecosystems on themselves, cybernetics, which is the relationship between algorithms and life beings, humans and machines, you have UX. So I have the different entities that radiate intelligence, and the new world, the world we are entering now, is one in which algorithmic intelligence are becoming pervasive. And this ecosystem that already existed, because everything in the world, in the universe, radiates intelligence and creates information, and there is a very complex network of information going on. Now with AI, etc., it's becoming even more complex, of course. And we have to think about intelligence, I think, as an ecosystem. I won't talk about the LLM OS. It's interesting. I just mentioned that I do an intelligences workshop. I do it with kids. I do it with adults. By the way, it doesn't make any difference. Both are equally intelligent in what respect. Playing even with mathematical concept, with physics concept, with machine learning concept. We do all sorts of activities. It's quite fun. And it's also a collective form of exploring around intelligences, right? So it's very fun. And I think I had another project to show, but I think I'm gonna finish here because time is short. So thank you very much. I don't know if we have 2 minutes for questions. I don't know.
Thank you so much. I absolutely love the idea of kind of happening upon data visualizations in nature, sort of by serendipity. And I will I'm very much excited to be sensitized towards the existence of these out there. How did you come across these, by the way? These data visualizations that exist, like the press marks on the door and the weights and stuff like that. How did those come to your attention?
Well, for the starters, I think they are everywhere, and if you open your senses to them, you're gonna start seeing them. They're everywhere. And I started reading Borges very early in my life, very, very early. So this kind of postmodernist approach to reality, in which the code of reality mixes with the reality, it's something that has always excited my mind in some way. So I'm kind of sensitive to also the humor of objects. That's also something that I love try to find everywhere where I look. So I guess, and by the way, there are other researchers that have been doing this kind of collections as well. So I'm not at all the only one to do this, but yes, I love my little collection.
That is great. Yeah, and I like too that the one good way to become kind of sensitized to these things is to read Borges. I think that's there's many good reasons to do that, but that's a good one as well. I really appreciated sort of ending with an ethical imperative. I think that recognizing intelligence everywhere and intelligent systems everywhere, it does kind of put a ethical burden on us to look at our role in new ways and to see perhaps the suffering of creatures that we wouldn't necessarily we may not notice. And so I think that's really exciting. I love the work that you it's been now part of the Envisioning Intelligences, and I really appreciate you taking an hour out and introducing us. This has been a feast. Thank you so much.
Thank you very much. I'm going to continue looking at the next presentation. This has been great.
Okay.
Thank you.
Oh, one more question, Santiago. If people are interested in taking that workshop, is there a link to it on your the Moebio?
No, it's I don't have it. I'm building a website for the workshop, but the
Okay.
idea is that any institution can just say, "Yeah, I would like to do the workshop," and invite me to do it, and it's like a 4 or 5 days, very playful event for anyone.
That sounds fantastic. I would certainly take that. Yeah, absolutely. All right. Thank you so much.
Bye.